Welcome. We are excited to present Peccavi, a visual paraphrase attack-safe and distortion-free image watermarking technique specifically designed for AI-generated images. This work is a collaborative effort across BITS Pilani, Triple IT Delhi, Stanford University, Amazon AI, and Meta AI. To the best of our knowledge, Peccavi is the first ever watermarking technique proposed to resist automated AI-based paraphrase attacks on images. Before we dive into the technical nitty-gritties, let's take a moment to understand the motivation behind this work. Why the great power of generative AI comes with great responsibility today.
According to a study, 90% of online content will be AI generated by 2026. And this is a billion-dollar opportunity right there. Just as cyber threats created a massive security industry, the next big tech gold rush isn't in creating more AI. It's improving what's real. As someone who's built AI products for the past decades, I'll show you 3 massive market opportunities that I think are still wide open. First, enterprise AI compliance and authentications. Companies will pay premium prices to ensure that their AI content is both authentic and compliant with emerging regulations. This space is wide open for tools that can verify content creation and modification processes, offer AI bias monitoring and transparency, and provide certifications for law like the EU AI Act. Think GDPR compliance, but tailored to the AI era. The second is what I think of the creator trust layer. Imagine a verified page, but for authentic and transparent content. Creators will need tools that prove their work is authentic and highlight the AI contributions, embed invisible markers or watermarks to trace the origin, and build trust with platforms and audiences in real time. This will be the evolution of creative authenticity in the age of AI. The third is moderation and validation for AI-generated content. The rise of AI-created media creates a need for platforms that can detect and block inappropriate or harmful AI-generated content automatically, validate the accuracy of AI-generated educational and professional material, and certify originality and track content across the internet. This isn't just about stopping deepfake, it's about safeguarding trust in the digital ecosystem.
While AI-generated content floods the vast expanse of the internet, the protective ozone layer, a metaphor for truth and accountability, is being pulled down. In a striking shift, the major social media giant Meta has announced its retreat from fact-checking, signaling a perilous erosion of safeguards against misinformation. This moment underscores the urgent need for new defenses in the digital age, where the power of AI demands renewed vigilance and responsibility.
We're going to get rid of fact checkers and replace them with community notes similar to X, starting in the US.
That's Mark Zuckerberg announcing that Meta is going to stop working with fact checkers. It's ending the program that's supposed to keep misinformation from spreading. For almost a decade, Meta has worked with fact checkers who review content and rate how accurate it is. When that ends, all kinds of lies about climate change, clean energy, miracle cures, even fake celebrity deaths could go unchecked on Facebook, Instagram, Threads, and WhatsApp. Advocates are also worried that the decision could lead to more hate speech online and even race and gender-based violence in the real world. Instead of working with fact checkers, Meta is going to copy a crowdsourced approach to content moderation that X uses. And we're seeing how that's going. Misinformation researchers tell The Verge that crowdsourcing fact-checking is a cop-out, that these companies are shifting responsibility to users to wade through hate and misinformation on their social media platform.
Let us reflect on a moment in history when the atomic bomb was in its making. Professor Niels Bohr, cognizant of the grave consequences such power could unleash on humanity, approached Winston Churchill with a warning born of foresight and concern. But Churchill replied rather dismissively, "After all, this new bomb is just going to be bigger than our present bombs, and it involves no difference in the principles of war." Yet, As history painfully revealed, the invention of the atomic bomb changed the principles of war forever. This timeless lesson reminds us that great inventions reshape our world, and with them comes the imperative to wield such power with wisdom and care. But wait, watermarking for images is a well-studied paradigm. Researchers have been studying it for 3 to 4 decades, and dozens of watermarking techniques already exist in the literature. So why do we need a new method? What has changed? In our previous paper, titled The Brittleness of AI-Generated Image Watermarking Techniques, examining their robustness against visual paraphrasing attacks, we introduced and categorically demonstrated the potential risks posed by visual paraphrase attacks. These attacks are fundamentally different from traditional watermark removal techniques, such as brightness adjustment, JPEG compression, Gaussian noise addition, and adversarial purification. The power of visual paraphrase emerges hand in hand with the great power of generative AI, unlocking new creative possibilities, but also introducing unprecedented challenges for image watermarking. Paraphrasing is a well-established area of research within natural language processing, NLP. For instance, sentences such as, "What is your age?" and "How old are you?" convey identical meanings despite their differing linguistic structures, thus constituting paraphrases of each other. In contrast, the concept of visual paraphrasing has not been as extensively explored, and we introduced the idea of visual paraphrasing previously in our paper. Modern Gen AI systems are capable of producing slight variations of a given image that maintain the duplicate semantic content while differing in visual presentation. In our proposed visual paraphrase method, we introduce 2 key parameters to control the degree of paraphrasing: paraphrasing strength, denoted as S, and guidance scale, denoted as GS. The paraphrasing strength, S, determines how much the image deviates from the original. A higher S allows for greater changes, while a lower S preserves more of the original image details. The guidance scale GS controls how closely the paraphrased image aligns with the text prompt. Higher values enforce stricter adherence, and lower values allow more creative freedom and variation. The challenging part is that visual paraphrase capable of erasing major or even all of the watermark signals embedded in the image, making all the existing watermarking methods ineffective. The fundamental challenge that lies before us is to uncover regions that endure amid transformation. The regions of an image that remain steadfast, unaltered, amidst the shifting tides of visual paraphrasing. We term these resilient sanctuaries the non-melting points, or NMP, the enduring fragments that preserve the soul of the image, withstanding transformation while holding fast to their intrinsic identity. To detect non-melting points, or NMP, we follow a 2-step approach. First, we perform saliency detection to identify the most visually prominent regions of an image, areas distinguished by features like color contrast, texture, and edges. Among several methods, we found XRAI to be the most effective, followed by MSINet, and use these for our experiments. Next, for each image, we generate 5 automatically paraphrased versions. We then identify stable regions that consistently appear across these variations by computing the intersection over union, or IOU. These stable, persistent regions are designated as NMP. To refine the selection, non-maximum suppression removes overlapping regions, retaining only the most representative patches. Each patch receives a stability score based on its frequency across paraphrases, with lower scores indicating higher stability. Once the non-melting points are identified, the next crucial step is embedding watermark signals within them. We experimented with 4 strategies. 1. Baseline watermarking using state-of-the-art methods like Zodiac, Stable Signature, and WAM. 2. Varying watermark strength. 3. Single-channel watermarking. And 4. Multi-channel watermarking strength. Our findings show that multi-channel watermarking in the frequency domain is the most effective approach for resisting visual paraphrased attacks. Watermark strength, controlled by the spacing between rings in the watermark, adjusts based on how consistently an NMP appears across paraphrased images. Regions present in more paraphrases receive stronger watermark signals. Embedding watermarks in the Fourier space, rather than pixel space, enhances robustness as it is less vulnerable to common image manipulations. We apply watermarks across different frequency channels for each patch to maximize resilience. Once attackers become aware of the non-melting points, the very regions where our watermarks are most securely embedded, they may attempt to specifically target these areas. Their goal would be to disrupt or degrade the watermark signals hidden within these stable patches, undermining the robustness of the watermark. This anticipation of targeted attacks compels us to develop additional safeguards, ensuring that even if these key regions are under direct assault, the watermark's integrity remains intact. To counter this threat, we introduce a technique called noisy burnishing. This approach involves adding carefully crafted adversarial noise to the watermarked image, which acts as a kind of camouflage. The noise strategically disrupts saliency detection algorithms, making it significantly harder for attackers to reliably locate the watermark regions. We evaluated the Peccavi watermarking scheme against several state-of-the-art post-processing watermarking methods, including Zodiac, Stegastamp, Stable Signature, DWT, DCT, SVD, and blind watermarking. The comparison involved common attack scenarios such as brightness reduction, Gaussian noise addition, JPEG compression, and visual paraphrasing at varying strength. We further tested Peccavi's robustness under variational autoencoder, that is VAE, based image compression, and stable diffusion, based image regeneration. Our results demonstrate that Peccavi outperforms these methods, maintaining stronger watermark detection across all tested attacks. Detailed results are available in the paper. We further evaluated the resilience of Peccavi against multiple rounds of paraphrase attacks, testing up to the third level of paraphrasing. Our experiments show that Peccavi consistently outperforms state-of-the-art watermarking methods such as Zodiac, WAM, and others. As depicted in the figure, Peccavi maintains stable and high detection scores even under strong, successive paraphrasing attacks, demonstrating its superior durability and robustness. For detailed results and methodology, please refer to the paper. You might still be wondering, what does the name Peccavi mean? Let me share with you the historical inspiration behind it. The term comes from a famous message sent by Sir Charles Napier, a British Major General in India, during his campaign in the Sindh province in 1843. Napier used the Latin word Peccavi, meaning I have sinned, as a witty pun on I have sinned, signifying his conquest of the region. This clever historical reference symbolizes war cipher and cryptid messaging long before Second World War. We adopt this name to pay tribute to Indian history. To conclude, Peccavi embodies a pioneering ecosystem for securing the provenance of AI-generated content across diverse modalities. Peccavi empowers resilient verification that withstands even the most complex and iterative processes of content editing and transformation. Whether AI-generated content undergoes multiple rounds of modification, paraphrasing, or format changes across text, images, video, or audio, Peccavi ensures the underlying provenance remains verifiable and secure. This robustness guarantees that the integrity of the original content is preserved, enabling trustworthy detection and attribution despite the evolving nature of AI-generated media. More to come in time. Stay tuned.